Hi guys, and welcome to the next lesson, pre-lesson 4, the periodic table. In today's lesson, as under the VCEA study design, dot point 4, the unit of area study 1A, the dot point talks about describing and understanding the periodic table as an organizational tool, identifying patterns and trends and relationships between the structures. So today, what we're going to do is we're going to look at the organization and identify the patterns within, some patterns within the periodic table. These later components will be talked about in the next lesson. The periodic table is a table to organize all the elements. So it organizes elements. It is organized in a couple of ways. You've got periods, which is the horizontal rows going across this way, all the way to the ends. That's a period there. And then you have the groups, which are vertical columns, so running down this way. All of these are vertical columns. The columns are labelled 1 through 18, as you can see, and the periods here labelled 1 through to 7. So elements are grouped by character within these groups and by character in the period as well. So for example, you have metals here, highly reactive metals, you have transitional metals here, and across here you have increasing number of electrons. So these becoming metals, moving into non-metals, and then moving into noble gases. So you can see trends moving across the table from left to right and up to down. We're going to talk about groups now. Elements are arranged in vertical columns, known as groups, I already mentioned, and these groups, they're used to determine the valence electrons in that element. So whenever you have an element, here is the electrons. On the outside, that electron here, that's called a valence electron. It's the outer shell electron. So in groups 1 and 2 over here, you're going to have this one here is going to have 2 valence electrons. Meaning it's going to have 2 electrons in its outermost shell. So its outermost shell, this one will have 2 electrons. For the group 1, will have 1 valence electron, which means when you were to draw it, its outermost shell would have 1 electron, as shown here. When you move to groups 13 and 14, what you do to work out the valence electron of these ones is you simply minus 10. So the valence electrons equals 3. Valence electrons equals 4, 5, 6, 7. And this one here has 8 valence electrons, which means it's a full outer shell of electrons. So as you move down, you are still having the same number of valence electrons in its outermost shell, but you have the total number of electrons is different. So you have 3 electrons, 11 electrons, 19 electrons. The number of electrons is different, the atomic number is different over here. However, the valence electrons remain the same. These all have 1 valence electron, these all have 2, these all have 3, 4, 5, 6, 7, 8. Transition metals are slightly different. They have varying valence electrons, and you'll be given those. You won't be expected to know them all. However, you're expected to know that if it's in this group here, has 1 valence electron, this group here 2, this group here 3, 4, 5, 6, 7, and 8. In a period, these are the horizontal rows as I described. These tell us about the electron configuration of the element. So the groups tell us about the valence electrons, and the periods here across left to right, right to left, they tell us about the electron configuration. So for example, magnesium is in group 2 here. Group 2, it's in the 3rd period. It's listed here. Its outermost electron is in its 3rd shell. So we know it has 2 valence electrons because it's in group 2. The periods tell us what the electron configuration will be. So it's got 12 protons because its atomic number is 12. So it's got 12 electrons because it's neutral. So therefore 12 electrons because it's neutral. So to make 12 electrons according to the Schrödinger model of the atom, electron configuration would be 1s2, 2s2, 2p6, 3s2. So its outermost shell is the third shell, so the third orbital here, because it's the period it's in. Outermost shell will be 4 for potassium and calcium, rubidium and strontium will be 5, cesium, etc. would be 6, and francium, etc. would be 7. Periodic table is organized into 4 main blocks. The elements in that block have the same type of subshell. So you have the S subshell, the S block here, the D block, the P block, and the F block. So all elements in this particular block have that particular subshell filled, will be their highest energy subshell. So these ones here will have the S subshell filled, these ones have the D subshell filled to some amount, some degree, and the P's are over here and the F's are over here. That's it for this lesson. So the key ideas are that the periodic table is made of groups or periods, and these are the questions to complete. Questions 1 to 5, chapter review 2.1 on page 41. Thanks.